Hi, this is Mrs. Cornitz, and so we're going to continue our work today um, using multiplication and division and um, fractions and measurement all together, um, just solving some problems. So the theme of this is volume of prisms, and if you remember, a prism is a shape that has the same shape on the bottom and the top. It has all straight sides, and those two shapes are connected by rectangles. So here we have a rectangular prism. There's a rectangle on the bottom and the top, and our first question here asks us how many cubes with an edge length of 1 inch fill this box. So, how many 1 inch cubes would fill this box? And so, to figure that out, we could find the area of this box. And to find the area, um, we multiply the length times the width times the height. So, we're going to do 4 times 10 times 3. And so 4 times 10 is 40. 40 times 3 is 120. So 120 cubic inches is our volume of this box. And since we're wondering how many cubic inches fill it, we'll need 120 of them. So since it's 120 cubic inches, we'll need 120 inch cubes. So then it goes on to ask us, well, what if the cubes are instead of 1 inch by 1 inch, what if they're 2 inches by 2 inches? And so a lot of people would be tempted to just say, oh, I'll just need 60 of them. It's twice as long, twice as tall. I'll need half of them. They would be surprised. So if it's 2 inches by 2 inches, it actually is 8 times larger. Here's our 1 inch by 1 inch cube. And so 2 inches by 2 inches by 2 inches, we end up 2 times 2 times 2 is 8. We end up with our 2 inch cube has a volume of 8 cubic centimeters. And so if I take my volume of my prism, 120, and I divide it by the volume of my cube, my 2 inch, 2 by 2 by 2 inch cube, which is 8 cubic centimeters, I end up needing 15. I needed 120 1 inch cubes. I need 1/8 as many. I only need 15 of these cubes. Whoops. I need 15. And then it asks, if the cubes had an edge length of 1/2 inch, would you need more or fewer cubes to fill the box? So we could pretend that this cube, instead of being a 2 by 2 by 2 inch cube, we could make this our 1 inch cube, and our 1/2 inch would be right here, half plus another half. And so, oops, let me get the text, turn it back to black. So if I find the area of that cube that measures 1/2 by 1/2 by 1/2, it's 1/2 times 1/2 times 1/2 equals 1/8. And so it takes 8 of these to equal this. And so if we did that 120, I need another text box, I'm sorry. So if I do, Pete's sake, if I do 120 divided by 1/8, that would be the same as 120 times 8. because when I'm dividing by a fraction, I can multiply by the reciprocal. So 120 times 8 is going to be 960. Well, 960 of those little cubes, of those half inch by half inch by half inch cubes. So if you use 1 inch cubes, it takes 120. If you use 2 inch cubes, 15. If it takes half inch cubes, 960. Quite a big difference. So now we'll do a little more work with volume and fractions. And so this problem says Claire's recipe for banana bread won't fit in her favorite pan. The pan is 8.5 inches by 11 inches by 2 inches. So a standard cake pan. The batter fills the pan to the very top, and when baking, the batter spills over the sides. To avoid the spills, there should be about an inch between the top of the batter and the rim of the pan. Claire has another pan that is 9 inches by 9 inches by 2.5 inches. If she uses this pan, will the batter spill out over baking? Will the batter spill over during baking? And so we know that her batter completely fills this pan right up to the top, just with the batter before it even starts baking. So we know the volume of the batter. We can figure out the volume of the batter by figuring out the volume of the pan. So let's go ahead and start there. So to find the volume of the batter, we're going to be 2 times 11 times 8.5. Which is 22 times 8.5. And so 22 times 8 is going to be 160 plus 16, so 176. And then 1/2 times 22 is going to be 11. So that equals 187 inches cubed. So that's the volume of our pan, or the volume of the batter. It's both. The volume of the pan is the volume of the batter because batter fills it up completely. Now, we want to know, will that fit in here? And it says that it will cook okay if there's an inch between the top of the batter and the rim of the pan. So in this case, this pan is 2.5 inches tall. And so I need the batter to only fill it up 1.5 inches. So I can see what this volume is, 9 times 9 by 1.5 inches, and see if that is equal to or more than this 187 inches. All right, so let me get another text box. Let me see if I can get it to let my cursor in. All right, 9 times 9 times 1.5. I need to leave that inch for the batter to rise. All right, so 9 times 9 is 81 times 1.5. So 1 times 81 is 81. Half of 81 is going to be 40. Oops, not 10. 40. And half of 1 is half, 40.5, which is 121.5. Inches cubed. Oh, it's not even close. This is not big enough to take it. And we probably could have guessed that, thinking that one side is just a half an inch longer. The other side is 2 inches shorter. 9 is 2 inches shorter than 11. And then 1.5 inches tall it's just not going to work. So no, this other pan will be worse. It'll be spilling over even more. So, again, just like yesterday, these are ideas that we can figure out. Using fractions gives us a little bit more of a twist to that, but that's okay. We are fine with that. We just take our time, use what we know, pull something else in, take try it out, see what happens. You can do this. These are slightly trickier, a little more involved, which truthfully for me, I think makes them a little bit more fun too.